Hello and welcome to this physics video, the electric field U10.EFd2. And today we will be drawing and interpreting electric field lines. I already drew the electric field lines because it would take too long to draw it and to talk about it. So I drew a couple of examples and now I'm just going to talk about how electric field lines work. So the electric field lines always begin at a positive charge or at infinity. The field lines they radiate from the positive charge, and likewise they go to the negative charge. That's where they terminate, or that's where they end. Also, another thing, E, or the electric field, is stronger where the field lines are close together. And this is true right here. As you can see, all the arrows are kind of clustered at that point. That's probably the strongest point in that electric field when the lines are very close together. Likewise, when they're spread apart, they're not very strong. They're weak. No two field lines from the same field can cross each other. That's just a rule. Whenever drawing field lines, you don't do that. It doesn't exist. And also the purpose of electric field lines. It's just they're not actually real. They're just there for people to visualize them and to understand where in an electric field where it would be stronger and where it would be weaker. Electric field lines, they accurately and effectively illustrate that point. So here we have an example of an electric field. On the left we have a positive charge and on the right we have a negative charge. Now these two charges are at the same magnitude, and you can tell this because the same amount of charges, or the same amount of field lines that is coming from the positive charge, is terminating at the negative charge, meaning that they are the same magnitude. If you look at the negative charge, you see how everything's clustered together there. That's where it's strongest. Likewise, all the field lines are emerging from the positive charge. So that's that. Let's look here first. These are two charges that have the same, they are both positive, so they repel each other. So they are the same magnitude, but they won't connect because field lines have to terminate at a negative charge or at infinity, which is what's going to happen with these if you were to keep drawing the lines. They would end at infinity. And lastly, we have this. If you look here, you can see how obviously the lines are coming out of the positive charge, ending at the negative, but the amount of lines that are coming out of the positive charge are significantly less than the amount of lines that are terminating at the negative charge. If you look here, we can count 1, 2, 3, 4, 5, 6, 7, 8, 9, about 10 lines coming from the positive charge, and here at the negative one, I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Many more lines there. This means that the negative charge here has a greater magnitude or a greater charge than the positive charge. So more field lines are going to cluster there. It's going to be stronger there at that point. So there you have it. Today we drew some magnetic field lines and we interpreted them, and we understood the rules of how they are drawn and how they are understood. So thank you for watching, and I hope you enjoyed the video.